Hello everyone. This video is about the task 5, feeder overcurrent protection and the programmable logic. Also, we will learn how to use the virtual input and outputs and use them for controlling the process. Let me visually show how it should work in this video. Just a second. Okay. Now let's go to the relay. In the relay, you can see there's like function button 1, function button 2, function button 3. They are like you should make them mimic also so that we can see their state. And this is the actual function buttons. 1, 2, 3. We will work with this. It works like this: that if I press this one, this LED, the fourth LED will be on. And if I press F3, it turns off. If I press this, then I press this with a gap, these two will be on, like this one turns this one on. But if you press both of them at once, the third LED, this one will like turn red. And the red in our program means that our overcurrent function is blocked and it will not work. And by pressing F3, it releases them. So let me show you how our overcurrent works. Here I have activated the virtual like injection. Here I have put 2000 like cycles. For the current, let me put, for example, 150 amps. And if I press start, you would see 150 ampere is here, and it is, and then after like 5 seconds or something, it did the tripping, disconnected. Now for releasing, you press this button like 3 times, come here, release, and then you have to release the contacts also. And now I will increase the trip to 200 amps, the injection like injection current to 200, and it will like trip faster. Now I start it. You see 100, 200, and like in 1 second or 3 seconds something, in 3 seconds about, it like tripped, and it basically relevant to the trip mode. And now I will release this again. Now I will press these 2 buttons, and now you see this red LED is on. The red LED is on means that the overcurrent function is disabled, blocked basically. Now I am injecting the same 200 ampere. Last try, in 3 seconds it tripped. Now I start, I wait for it, and nothing is gonna happen because I have blocked it with the function buttons. You see 10 seconds passed and nothing has happened. Now I stop it and I release the block. The block is released when I press the function button 3. And now inject again, and 3 seconds, yeah. Less than 3 seconds, it's blocked basically. The trip happened. So this is what we are going to do in this task. It's a bit complicated, but I made the file that will be like make the life easier for you if you just follow that. Just try to understand what's happening there. So let's go to the PDF file and then okay. Now we go to this file. Here I've explained everything, like what to do step by step. These settings you can read, like all the parameters that is needed. From the beginning, what we have to do, we have to follow some steps. First, we select which relay we want to work. There's 8 relays, and according to that, we have to set the IP address for the draft project that we are downloading from the Moodle. We download the draft project from the Moodle, then modify the IP to be matching with this relay that we have selected. This is the IP. For example, I have selected to work with the highest relay. I will put it like I21, like 1.21, the end of the IP. And for the same relay, I have to modify this name to be protection relay 1 IP21. So if you make this by mistake, then you're using Ethernet IP for connecting. You connect to the relay, you download wrong IP to the relay, then your connection will be broken. You cannot connect to it anymore. So please pay attention in the beginning to this, that if you have relay number 1, here's 21. If you have relay number 7, it's 27. So after modifying this IP, you will go forward to set the scaling, scaling parameters for the values of the CT. I have made as simple as possible that you can just follow. These are what you need to do. After that, the 6th step is to enable the protection, overcurrent protection. It's ANSI 5051 67-1. All the changes that you need is here. You see 132. You can check why they are these numbers here. In the class we can talk about it also. Then after you download this to the relay, you will use the virtual injection for filling this table. You give different currents, you inject different currents to the relay, and based on the time that takes for it to trip, you measure and put these times here. And then for some groups, if we can, we will do this. So after this virtual injection, you will go to the test with the test device also. And so these numbers will be a little different. We can think why they are different. With the tester device, you will insert these numbers. So if you insert 4.38, this is the secondary value, secondary the CT current transformer, and it on the relay it will show 132, for example. So you will insert these numbers. 5, for example, it shows 151, because these are the ones that I injected myself. So you will, if you inject this one, for example, 4.7, you see 142. You inject this and then measure the tripping value. This will be read from the tester device, and then approximate value is missing here. So important note here is written for the tester device is that you should connect the X1 and what is this? X1 connection 17 and X1 contact 108 to the binary input of the test device. So this digital output 4, which is on the relay, when trip happens, we want it to connect and it will give us the feedback signal, and we have to, in output matrix, also connect it. We have to connect this one with the global trip. When it happens, we this contact closes and gives us the signal. And the tester device injection is this like this, that you go to the AC test, IA input, you put for 4.7 here, you write it down yourself, you press start, and you should have the trigger on the OR situation, and all of this ticks should be on. Then yeah, you put it start the injection, and it starts measuring until gets the feedback, and the time will be registered here. This is the time of the tripping, how long it took until the trip happens, and what was the value of the injected current, which is the same as this one. So this will be recorded in the files here, so we can read them later also, but you don't need, you just read it right away after every injection. And the connections should be like this. Basically, you need the feedback that comes here for these two pins, a binary inputs, and then current outputs is from here. So this black one is the COM, and you want to connect to one of the phases only, so you need only these two wires. So, and then after collecting the information here, you can make your points here also and draw another graph to show, like, this is a test that I have made, but your values might be different, so you can put mark here different points. Another example, you can see how the time injected current and the time or trip time is related. The bigger the current, the faster the tripping is happening. And then the second part of the, so if everything works here, you have done the first part. The second part is like configuring the buttons. I explained how it works in the video. First, you should make the mimic. You have to have this virtual input 1, 2, 3. These are like you have to activate by putting this sticks here. So you activate them, and these F1 and F2 and F3, they are basically text. One text here, here, here. You add here, then. The next will be, you go on the control tab, set the function F1, F2, and F3 function buttons to control virtual input 1, virtual input 2, and 3. So these are function button. You want to configure them that selected control. You control these 3, and the function buttons can send different pulses. This means every time that you press this function button, how long the pulse length should be. If it is 0, it will be on. It means infinite time. But for our case, we need 0.1 second. So whenever we press this, we want 0.1 second. The signal be on and then turn back off. So these are the function buttons configuration. First you do that. Then configure function buttons and virtual input pulse width. So that was the function button, and then virtual inputs also. You can set their is it, yeah, here you see virtual inputs. You can set their pulse width also, that you want them to be on only 1 second, and then go back to the 0. And then on the programmable logic, create these logics that you see here. The first part exists, so you don't need to touch it. Just let it the way it is. You like you use, these are virtual input 1, 2, and 3. Based on them, we want to set logical outputs 3, 4, and 5. So you set these ones, and we will use the logical outputs for in the matrix. Yes, you go then here to the to this lead matrix. So logical outputs will be there controlling the lead matrix, lead D, lead E, and lead F. Then the block matrix, we have to set that block matrix are our logical output 5. We need to block only when the logical output 5 is on, is set. We want to block the overcurrent function, and that's all the setting. And after the setting, you just come here, press the functions, and see everything is work. Block test is work the way that I showed here, and then answer these questions, and that will be all. So I hope everything is clear, and there will be no problem for you making it. Just whenever working with the tester device, let me control all of the connections. Thanks.